Okay, hi guys. So I'm going to give you guys some notes on creating flowcharts. These are going to be real short notes, and then I'm going to get into showing you guys some examples. So here's a very, very basic flowchart. What it is, it's a schematic representation. So you guys have seen schematics pop, probably maybe blueprints of the layouts for a building, or maybe a schematic showing how a particular electronic circuit is designed. This is just a flow chart that shows how a process is supposed to move forward. So very simple example of feeding the dog. Is the dog's bowl empty? If not, then we just end the process. If it is empty, yes, then pour food into the bowl and then stop your process. So here are the different parts of a flowchart that you're going to need to know. You always have a start button. That always has to be the beginning of your flowchart, is a start. And then there may or may not be an end. Not all flowcharts are going to have an end. A process is going to be this rectangle shape. Input and output is going to be this parallelogram rhombus shape. Wait, no, this one's the parallelogram. That's a rhombus. I'm not a geometry teacher. The diamond shape is usually what I call it, is your decision, yes or no. And then you've got arrows to show the direction through the flowchart. And the last one is a display. So if you're using some kind of machine that has a display window of some kind, a computer screen or a digital display, that this is what represents displaying information. Okay. So then this slideshow is going to go through some more examples of each and every one of these. The start and end flowchart. You may not have an end necessarily. Sometimes flowcharts will be a continuous process of checking again and again and again, and there's not actually an end to it. It's just an eternal, infinite loop that's cycling through again and again and again. So sometimes you'll have an end, but you may not necessarily have an end in your program. Okay, so the process. This is an actual action that is part of the process. It is a verb. It is something that is being done. So we have maybe add one. Maybe you actually are doing a counting program, and so you're adding a number. Maybe there's a motor that needs to be turned at a particular time, or a light needs to be turned on and off. Or food needs to get dumped in the dog's bowl. The input and output, that is information that either needs to get put into the program for it to be able to run, or information that the program is spitting out, that it is giving to you. So maybe you have to type in the weight of something. Like maybe when you're at the grocery store and you're checking out, and they're like scan a bunch of bananas or something, and then they have to like type in some information, and then the program will let it continue on. Could be something like that. Maybe it's a diagnostic piece of a car that's checking the balance between tires. Or maybe it's time that it takes for an operation to occur, or the time that the operation has to start. The decision, that is your rhombus shape or diamond shape. The outcome to this either has to be a yes or a no, and so usually one of those comes out of the bottom, and then the other goes out one of the two sides. So maybe this is the yes and then this is the no, or vice versa. Doesn't really matter. But there should always be either a yes or a no answer to a decision question. Arrows, again, just lead you through the flow chart. Here's an example. So for this example flow chart, we want to count from 1 to 9 by odd numbers. And before we start actually drawing that flow chart, let's determine what the output is going to actually be. And let's determine what first block we need to use. Okay, so our goal is to count by odd numbers from 1 to 9. That means our output is going to be 1, 3, 5, 7, 9. Always start with a start block. So if we get started with this flowchart, we can have a program that begins like this, and then the first thing that we want the program to output is number 1. So we can input the number 1 or have the computer state 1. Now that we've got that, we need to state the next number. So we can just state 1, 2, we can just state 1, 3, 5, 7, but it would be more interesting to have the program perform a mathematical function each time. We started with 1. If we want to have number 3 come next, then we can just add 2. And then if we want to have number 5 come next, we just add 2 again. So maybe we can just do what's called a loop and have it go back through the flowchart multiple times. So the next thing that we would do is we would input the number, and then we would say the number, have the computer say the number, or you would say the number, however they're describing this. And then we're going to add 2 to that number. So we inputted 1, we said 1. Now we're going to add 2. And if we do that, now we need to make a decision. Is the number greater than 9? If we do 1 plus 2, that's 3. Is that greater than 9? No. So we are going to go back up and say our number. So now we're going to say 3. And now we're going to keep going, add 2, and then that would be 5. 5 is not greater than 9. So you go back up, say 5, add 2, that's going to be 7, say 7, add 2, that's going to be 9, say 9, add 2, that's 11. So at that point, the number is greater than 9, and so we would end the program. So that's one example of how you could create a flowchart that counts from 1 to 9 by odd numbers. There's, of course, different ways of doing this. You could do the say the number after the decision and make this is the number greater than 5, or is the number greater than 8 or something, and say the number afterwards. So there's other ways that you could set up this flowchart. This is just one example of getting the output that we want. There's more than one way to get your desired output. It's just about finding the most efficient way for whatever it is that you're having to do. Okay, now one thing that I'd like to see you guys try is creating your own flowchart. Maybe it's a flowchart of how to pour a glass of milk. We talked about making flowcharts for making a peanut butter and jelly sandwich, or a flowchart for washing your hands. I'm gonna let you guys decide what kind of a flowchart you might wanna create. But what I must see from you is that you are using these parts of the flowchart. And you don't have to, I mean, if you don't get them perfect, that's okay. I'm not so much going to be grading on is it a perfect flowchart as opposed to are you getting the chunks of the steps down. Like if you make something, if you give something a rectangle when it really should have probably been an input output, I'm not going to be concerned about that. I'll identify it, let you know so that you know how to correct it. But I'm not going to be dinging you little points here and there just for not quite understanding the difference between those two. Because it does take a little bit of practice to kind of see when you apply it to different scenarios, what things should go where. Let me actually give you some more examples of flowcharts. And here we go. Good old PLTW website. Nope, not looking at it. All right, first example that I'm going to show you, this is a flowchart that I created actually for our robotics class for testing batteries. that I haven't actually shared with any of the robotics classes. Shh, this doesn't happen. Okay, so in this example, we've got the start button. Then we perform an action. And so that's why it's a rectangle. Test the battery voltage. And then basically, this could be, I have it saying, what is the battery voltage? But really this needs to be a yes or a no. So let's make that, is the battery voltage acceptable? And so then, or if your battery voltage is high enough to be considered acceptable, then you would go on to the yes, return to workstation, and test another component of your machine. Then too low. So notice that these two, they're the parallelograms, and that's because they're output from your voltmeter. So then next decision, is a charger available? Yes, charger's available. So plug your battery into the charger, and then you would go on to the next piece. And then no charger is available. Are there any chargers reading green? If it's green, then that means it's charged. Yes, remove the batteries from any chargers that are reading green and put them in the charge box. No, place your battery in the not charged box. And then we come down here, are there any batteries in the charge box? Yes, take a battery that's fully charged. No, end. I guess I don't have anything for this particular part. I didn't give this any kind of a resolution. But that's an example of a flow chart and some different, like the inputs and outputs. I don't know that the yeses and nos need to be in parallelograms. I put them there, but that's not typically something that has to be done. You can also just put like yes and no next to the little arrows and not actually put it into a parallelogram. Here is, well, before I get on to the next examples, the final project for this unit on machine control is supposed to be a marble sorter, where you take a bunch of different marbles that are different types. So maybe some are acrylic, some are glass, some are wood, some are metal. And you're supposed to be able to dump them into a machine that you guys build out of the VEX equipment, and then have your machine automatically sort them into their different types. I don't know how we're going to work with that this semester because you guys don't have access to those tools. But there are some different virtual things that I think I can have you guys do instead. But I thought I would still show you my example flowcharts so that you can see from basic to very advanced flowcharts. So first, let me show you guys. This is an example of one of the marble sorters that I think is pretty strong. Here we go. It has some nice music to it.
This is the final product of a robot sorter. Our robot ended up sorting 10 marbles into 4 cups in 48 seconds. This is how it did that. The 10 marbles were separated up here by a rotating device made of flat bearings. One by one, the marbles slid down and dropped onto a seesaw that allowed the heavy marbles to be separated from the lighter marbles.
Here, the clear red and blue marbles are stopped so that they can be read by a light sensor. The marbles are then separated by values produced when a flashlight is shown on them, and after a few seconds, the trapdoor swings open for the marbles to fall into its designated cup. Based on the light value the marble is identified as, a motor that's been programmed will turn multiple gears to move the right cup under the trapdoor.
Our original designs had a piston that would push the marble onto the seesaw, but it also had a rubber gear separator, but we realized that these were too complicated and not the most efficient. After several tests and modifications, we ensured that this marble sorter would work with both speed and accuracy.
Okay, so that is one example of a marble sorter. And then here is Whoa. Another example.